The data exchange between the individual control system within an area, but also across areas, is an essential functionality in every classic control solution. Braumat has always offered an integrated project planning interface for this purpose. With version 8, mixed operation between the semantic control families S7-400 and S7-1500 can now also be realized. My colleague Horst Fuchs will now show you how the individual configuration and parameterization steps for this data exchange are implemented. Thanks, Jürgen. So, during the next few minutes, we'll try to explain cross-coupling in Braumat. Like in all classic control and project solutions, we have to exchange data between the AS levels from AS to AS. This can be commands, signals and data packages. Everything that needs to go from controller A to controller B or C. Here we have a classic Braumat area in mixed operation, which means we have an S7-1500 family in mixed operation with an S7-400 family in one project. Despite this, with version 8 we can now also exchange data between the various AS types. This is done as follows. First, we have to configure our area completely, including the various AS with the corresponding IP addresses. Also at the controller level. If it is Ethernet, an Ethernet address is added here. This should then all mean that the servers, these two redundant servers, couple with the AS. This is the basic requirement for a functioning cross-coupling. You probably know that a cross-coupling always needs the integration of the send-receive function block, usually in STL. We have already integrated this in the Braumat system. This means that for you, this cross-coupling would then only be necessary for parameterization. As a basic requirement, however, it is still necessary in Semantic Manager, if you go to Connection in NetPro, to create a new connection, an unknown connection with the corresponding IP address of the partner. This is you locally. You can then see this online. As soon as you see this green triangle here, there is a connection between this AS and this AS, or here to here. The same needs to be done for TIA parallel. To do this, go to Device Connection in your AS and establish an S7 connection with the corresponding external address. Once these two settings are in place, you can continue with the further parameterization. You can do this classically with Braumat parameterization, which you can find in the menu under Engineering, under Block Parameterization. Here we have to do two things, which I've prepared here. Here are the XC PCU objects. There is this class for every PCU. You have up to 32 connections available. Locally, I am this PCU 3 or 5, so it doesn't count. So you can create connections to a total of 31 PCUs. We do that now for the PCU 5 or 4. Locally, I am on the PCU 5. This is TIA parallel S7. From this parameterization, this one here, and I establish a connection to the PCU 4, the S7-400. The same thing happens from 4 to 5. The connection running status information tells us that we have established a connection both in NetPro and in TIA parallel. and that the connection is also established in Braumat. And now we can combine corresponding data packages. We can also do this in the parameterization. To do this, we have another object in each PCU, the XC job class, with more than 900 connections. Here, we need to make a distinction. Do I want to send from the PCU 5 to the PCU 4? This is my remote AS. In other words, I can send GET or PUT orders, meaning I either receive something or send something. Accordingly, source pointer and destination pointer describe from which data block address we want to send or receive data. Of course, the same goes with flag areas. You can also enter flags as the origin or destination, for example, to send ICM valve motor signals from one AS to another. So that's everything on the orders. They are activated here with Enable and then run cyclically in accordance with a specific timer. In order to better understand all of this, I show you a prepared process image in which we have established exactly this cross-coupling between PCU 4 and PCU 5. Below are the examples for NetPro and TIA Portal once again. Now, for example, I activate a job, a GET job. In other words, I take a data package of 5 data from PCU 4 and send it to PCU 5. In this case to the same DB, the same area. We will see that this works if I change a value here. After a corresponding timer run, the value is brought over here. I can do the same by establishing a PUT job in the PCU 4. This means that I now deliberately send this data package here. I don't take it from the PCU 4 to the PCU 5 as I did before. This also means a change in value leads to a change in the corresponding data on this page. It's exactly the same in the other direction. You decide whether you want PUT or GET. We always recommend a GET command. In other words, I deliberately fetch data from a remote PCU. For safety reasons, if I write something and have an error somewhere, I might write in a running AS in data areas that might cause me problems. This button here in the process image means that I activate this job. This is the timer within the job. And now we come to the commands use case. We already know the valves and motors in Braumat. If I now want to control a specific valve from or in a remote PCU, I can of course do this by configuring a pseudo valve in my destination PCU, which I do not control externally, but whose commands and flag values I simply take, misuse, in order to control an external ICM or other ICM in the remote PCU. Okay, let's summarize. It really is this quick and easy to execute cross-coupling between AS, NetPro, TIA Portal. Create the objects and individual data packaged in the parameterization, activate everything, and then data exchange will take place cyclically in the background.
Siemens. Ingenuity for life.